Good good day to all of you. Myself Savant Kumar Bhaskar, working as an assistant professor in Shiv Shankar College of Agriculture Engineering, Mirasgaon. Now today we will discuss on the topic that is mechanical properties of materials. Introduction. The practical application of engineering materials in manufacturing engineering depends upon thorough knowledge of their particular properties under a wide range of conditions. The term property is qualitative or quantitative measures of response of material to externally imposed conditions like forces and temperatures. However, the range of properties found in different classes of material is very large. Classification of material properties: chemical, physical, mechanical, and dimensionals. Chemical: composition, oxide or compound, acidity or alkalinity, weathering, corrosion. Physical: density, conductivity, thermal, electrical, accuracy, sound, transmission, absorption, optical, combustivity. Mechanical: strength, tension, compression, etc., toughness, stiffness, elasticity, plasticity, ductility, brittleness, hardness. And dimensionals: size and shape. Mechanical property: the properties of material that determine its behavior under applied forces are known as mechanical properties. They are usually related to the elastic and plastic behavior of material. These properties are expressed as function of stress-strain relationship. A sound knowledge of mechanical properties of material provides the basic for predicting behavior of materials under different load conditions and designing the component out of them. Stress and strain relationship: experience shows that any material subjected to a load may either deform, yield, or break, depending upon the magnitude of load, nature of material, cross-sectional dimensions. The sum total of all elementary intermediate forces or internal resistance which the material is called upon to exert to contract the applied load is called stress. Mathematically, the stress is expressed as force divided by cross-sectional area. Here is I have shown the different figures. When you are applying stress, then there are changes. Stress is denoted by sigma and it is equal to the formula force divided by cross-sectional area, F divided by A. Strain is the dimensional responsible given by material against the mechanical loading deformation produced per unit length. Mathematically, strain is change in length divided by original length. Here is I have shown two examples. Number first is A and number second is B. When you applying the load, their original dimension is L. When you applying their load, then it will be changes L plus another one dash. That is, you will found strain. Strength: the strength of material is its capacity to withstand destruction under the action of external loads. It determines the ability of material to withstand stress without failure. The maximum stress that any material will withstand before destruction is called as ultimate strength. Elasticity: the property of material by virtue of which deformation caused by applied load disappears upon removal of load. Elasticity of material is the power of coming back to its original position after deformation when the stress or load is removed. Here is I have shown the elastic, linear, non-linear elastic and elastic linear, force and sigma. Here is I have shown again another one example: before loading, after loading is reformed during loading. How this will be changes will be happened inside the stress and strain. Young's modulus is equal to the stress divided by strain, and the stress is nothing but as a formula we know F divided by A. That is F is force, A is area, and strain is equal to change in length per unit original length. Plasticity: the plasticity of material is its ability to undergo some degree of permanent deformation without rupture or failure. Plastic deformation will take only after the elastic limit is exceeded. It increases with increase in temperature. Stress strain curve shows elasticity and plasticity for material. Here is I have shown another one example of stress strain. Example: stress is denoted in vertical line and strain at the horizontal line. When you applying the load, how changes will be occurred in that material. First elastic deformation, second one plastic deformation, third one is neckling, and last one if you are applying too much load, then it will be material will go to failure, that is fracture. Stiffness: the resistance of material to elastic deformation or deflection is called stiffness or rigidity. A material which suffers slight deformation under load has a high degree of stiffness or rigidity. Example: steel beam is more stiffer or more rigid than the aluminum beam. Ductility, it is the property of material which enable it to draw out into thin wire. Example, mild steel is a ductile material. The percent elongation and the reduction in area in tension is often used as empirical measure of ductility. Here is I also shown the example of ductility. This one is again example of ductility, elongation, reduction in area, stress and strain by using curve. I have also shown what changes will be occur in ductility material. Malleability of material is its ability to be flattened into thin sheet without cracking by hot or cold working. Example, lead can be readily rolled and hammered into thin sheet but can be drawn into wire. Comparison of ductility and malleability. Ductility and malleability are frequently used interchangeably many times. Ductility is tension quality while malleability is compressive quality. Resilience, it is the capacity of material to absorb energy elastically. The maximum energy which can be stored in body up to elastic limit is called as proof resilience, and the proof resilience per unit volume is called as modulus of resilience. The quantity gives capacity of material to bear. Here is also I have shown examples of resilience. Resilience is nothing but it is the property of material to absorb energy and to resist shock and impact load. It is measured by amount of energy absorbed per unit volume with elastic limit. The property is essential for spring material. Hardness is a fundamental property which is closely related to strength. Hardness is usually defined in terms of ability of material to resist to scratching, abrasion, cutting, indentation or penetration. Method used for determining the hardness: Brinell, Rockwell and Horquez. Brittleness, it is the breaking of without much property permanent distortion. Material is considered to be brittle. Example, glass, cast iron is its example. Creep, the slow and progressive deformation of material with time at constant stress is called scrape. Depending on temperature, stresses even below the elastic limit can cause some permanent deformation. It is most generally defined as time dependent strain occurring under the strain. This one is the example of grip. Here is if you are applying the pressure, there will be changes occurred in that material. Here is I have shown. Fatigue, this phenomenon leads to fracture under repeated or fluctuating stresses. Fatigue fracture are progressive beginning as a minute crack and grow under the action of fluctuating stress. Many components of high-speed aero and turbine engines are this type. Thank you, friend. In next part, we will see the another part of farm machinery design topic.